right. Let's find the length of the curve. Y is equal to x over 2, all raised to the 2/3 power, from 0 to 2. Now we're going to find there's an issue with our formula when we try and do this problem. So let's get into it and we'll see what our issue might be. So we're going to take our function, or y is equal to x over 2 to the 2/3 power. Now we're going to take its derivative, and let's write dy dx. And we'll let our 2/3 fall to the front. Times our x over 2, and let's make sure to subtract 1, so we get negative 1/3 power. And now we need to multiply by the x over 2's derivative, which is just 1/2. Okay, great. 2's cancel. And let's rework this and call dy dx is equal to, what's that, 1/3 times, oh, let's just flip this thing over, right? Isn't that what a negative exponent says, to the 1/3 power? And if you want to see it nice and clean, this is 1/3 to the cube root of x and the cube root of 2. I continue to write here, but really for only one reason, that, oops. I continue to write there because I'd like us to see that in our denominator, we have an x. And we need to find the length of the curve on an interval from where x is equal to 0. According to our theorem, f prime of x must be continuous. F prime of x must be continuous on the closed interval from a to b. F prime of 0 does not exist. So this gets us to a new sort of idea. What do? Well, shoot, let's do this in terms of y. So we have our other arc length formula where everything is in terms of y. Now we're going to go from c to d, what our y values of the function might be, with 1 plus, well, it's the derivative on x with respect to y, all squared dy. Now for this to be true once again, we're going to need to make sure that the derivative is continuous on our interval from c to d. So dx dy must be continuous on the interval from c to d. All right, well, let's go back to our problem. Let's use this thing. Let's see if we can't solve for dx dy. Well, dx dy, well, shoot. Let's go get it. We'll take our original function, because this ended up just being, well, a fool's errand. We take it, and let's take it right down here and see what we can do. So y is equal to x over 2 to the 2/3 power. And while we're here, let's get our bounds all changed up. So if we were to plug in x equals 0, it looks like we'd end up with 0. And we're doing this for y. And then when we plug in 2 over 2 is 1, and 1 raised to anything, I don't even need to look at it. That's just going to be 1. Cool, so let's solve for x in terms of y. So to both sides of this, we're going to hit it with a 3/2 power, which will just leave us with x over 2, removing what we had added there. And now we multiply by 2, and we get 2y to the 3/2 power is equal to x. Well, shoot. Let's go find our derivative and see what ends up happening. Let's turn it around and say x is equal to 2y to the 3/2 power. And now let's take a derivative on x with respect to y. So we still have our 2, our 3/2 power will fall to the front. And now we subtract 1, leaving us with 1/2. Let's clean it up just a bit. And it looks like we're just going to be left with, let's use a different color here, dx dy is equal to 3 times the square root of y. Ooh, I think this is going to work out well. So let's use our new formula and let's go figure out what the heck the length of this arc is going to be. The length, it says we go from c to d, but our c to d is just going to be from 0 to 1. Now we're going to take the square root of 1 plus the derivative on x with respect to y, which we found to be 3 root y. But we're going to square this thing up, and with respect to y. Let's get it. 0 to 1, square root of 1 plus 9y dy. Well, this is a simple u sub. I don't even think I want to do the u sub. Ah, what the heck. Let's do the dang u sub. Well, let's say that u is equal to 1 plus 9y. Therefore, du is equal to 9 dy. So we get 1/9 of du is equal to dy. Okay, so what do we got here? We can also change our bounds right now. La-di-da-di-da. We plug in 0, we get 1. We plug in 1, we get 10. Now we have, what is that? There's that 1/9. Square root of u du. Let's integrate it. So that's going to become 3 halves. So we're going to multiply by 2/3. So the 3 halves power. And we're going to evaluate that from 1 to 10. Geez, we're about there now, huh? 2 over 27 times u to the 3 halves, evaluated from 10 to 1. Well, it looks like our answer is not going to turn out to be all that clean, but 2 over 27 times, let's call it 10 root 10 minus 1. And if you're interested, it's about 2.27. But boo, there's the exact answer. And that's it.